Hi everyone, this is lesson 6.4. We're going to do more problem solving with right triangles, and in some of these questions we are going to be incorporating a second right triangle. Couple of goals for this lesson. What we want to be able to do is draw pictures, or I guess diagrams, using angles of elevation and angles of depression. So understanding what these are, where they go in a triangle, a right triangle. And then we need to be able to continue to solve problems using SOHCAHTOA. And just remember that SOHCAHTOA implies that we're using right triangles, okay? These two go hand in hand. If you have a right triangle, you can use SOHCAHTOA, but you can't use other equations. We're going to learn non-right triangle solutions in the next two lessons after this one. Okay, so let's talk about an angle of elevation and an angle of depression. So the first thing we need to talk about is what is meant by this word horizontal, okay? So horizontal is very literally the line that goes straight out in front of you from your eye level. So the horizontal line is if you were looking straight out into space in a straight line parallel to the ground, we would call that a horizontal. Both the angle of elevation and the angle of depression are measured with respect to a horizontal. So the way I want us to think about it is the following. If I'm thinking about an angle of elevation, okay, it's the angle upwards from the horizontal, okay? So I want you to think about how much your chin goes up or your nose goes up when you look at an object, and all of this is with respect to a horizontal line, okay? Same deal if you're looking down. So let's say you're high up somewhere, like standing on a building, and you're looking down, or even if you're sitting in the building in a window looking down, you still have this idea of a horizontal. So a horizontal is if you took your line of sight straight out, parallel to the ground, that would be your horizontal. Again, your angle is measured from the horizontal, but it's downwards, okay? So your angle of depression is this one here. Now, the reason this one is a little bit tricky is because sometimes guys want to put the angle of depression right here, and that's not true. In fact, we know if we were to think about a Z pattern, so if I were to think about a Z pattern from here, okay, the reason I keep saying the word parallel is if I know my line of sight is parallel to the ground and my angle of depression is this one, well, I also know that this will be the same angle. So if I were to label a second angle here, this is equal to the angle of depression. Okay, so beware. Okay, it is, how am I going to do this? Okay, it is not this one. Okay, it is not that one there. All right, so now that we know those two definitions, let's get started with some questions. Jane is on the 5th floor of an office building, 16 meters above the ground. She spots her car and estimates that it is parked 20 meters from the base of the building. Determine the angle of depression to the nearest degree. So this is Jane's building, and it doesn't matter how high the building is. We're going to say Jane is sitting in her office here. This is her. Okay, and we're told that her distance from the ground is 16 meters, and we know that the ground is always at a right angle to a building. So she looks out the window, and she looks at her car, which is somewhere over here. And anytime we have, an object, we're always going to neglect its height. So we're going to imagine that the car is just the dot on the ground. Okay, so for the purposes of grade 10 math, we don't care about how high this car is. We're just going to picture it as a dot on the ground. Okay, she spots her car and estimates that it is parked 20 meters from the base of the building. Okay, so the hypotenuse is not 20, it's actually this distance here. Determine the angle of depression to the nearest degree. So we're not going to get tricked by this. We know that this guy here, this is the horizontal. And we know that the angle of depression is defined as this angle, which is the same as this angle. So if I'm actually trying to find the angle of depression, I'm not going to make the mistake and think that it's here. That's wrong. Okay, we know that the angle of depression is measured from the horizontal. Okay, so we're going to draw it properly like this. Now what I should realize is that I'm going to use a tan ratio where this is my angle of consideration. I know tan theta is opposite over adjacent. And in this case, the side opposite of theta is 16 and adjacent is 20. And if you recall, the way we isolate this or the way we solve for the angle is we use tan inverse. 16 over 20. I'm going to get theta is 38.6598. And if you didn't get that, chances are your mode is not in degrees. Okay, so make sure that your calculator is in degrees mode. The angle of depression is 30, it says to the nearest degree, is 39 degrees. Very good. All right, next question. Kenny is looking out of his window of his apartment building and he notices a bird on the roof of a nearby building. The angle of elevation from Kenny to the bird is 34 degrees. Kenny also notices his friend waving to him in that same nearby building that lives 2 floors below Kenny. The distance between Kenny and his friend is 31 meters. If the 2 buildings are 25 meters apart, how far apart is the bird from Kenny's friend? Okay, I'm going to draw 2 buildings. Okay. And I'm going to know that they are 25 meters apart. I'm going to put Kenny right here. And it says that Kenny is looking out of his apartment building and he notices a bird. Okay, this is my version of a bird. It's not that pretty, but that's a bird. So, and we're going to reduce the bird to a dot. And we're going to say that, yeah, I'll use this, but here's the horizontal. Okay, and we know that the angle of elevation here is 34 degrees. His friend lives 2 floors below Kenny, so I'm going to say friend. And it says that the distance between Kenny and his friend is 31 meters. Now, it doesn't say horizontal distance, so I'm pretty sure, and in fact, I'm very sure that this is the line of sight distance. Okay? So that direct distance from Kenny and his friend is 31 meters. How far apart is the bird from Kenny's friend? So essentially, I'm asking us to find this distance. We can call this D. So we could look at this a couple of ways, but noticing and knowing what I know now about trig is that I really only know the trig of right triangles. So what I'm going to do is I'm going to break this up into 2 right triangles. And I'm going to draw them here. This is Kenny, this is bird, okay, and this is 34 degrees. I'm going to call this H1 for height 1. And then we have another right triangle. This is from Kenny to his friend. And I know that this is 31 meters. I don't know anything else. Well, actually, I do know one thing. I know that the distance from here to here is 25 meters. So both of these have a distance of 25 meters at the base of the triangle. I'm going to call this H2. And I think we can agree that distance is H1 plus H2. So I'm looking for the addition of those two heights. Okay, so let's look at H1. If I use this as my angle of consideration, I get tan 34 degrees is opposite over adjacent. This one's not so bad. I can see that H1 is 25 times tan 34 degrees. H1 is 16.8627. Can I do the same thing with the second one? Actually, the second one's easier because I can use Pythagorean theorem. 25 squared plus H2 squared equals 31 squared. I get H2 squared equals 336, and H2, if I square root both sides, is 18.3303. If you don't trust me, just you can stop this and use your calculator to figure those numbers out. So D is the addition of H1 and H2, and we will round this to one decimal place. They are, let me just say they are 35.2 meters apart. All right. And that's the friend and the bird. Cool. All right, here we go. Standing 15 meters in front of a building, you look up at an unknown angle of elevation to see the top. When you walk 10 meters directly towards the building and look up at the same angle, you see a window that is 6 meters below the top of the building. What is the angle of elevation you are looking at? Let's just break this down. Here's a building, and here's me. I'm a dot, okay? And I look up at an unknown angle of elevation to see the top of the building. We're going to call that theta. And then what I do is I walk 10 meters towards the building. We know that this is 15 meters, right? And then I'm going to walk 10 meters closer. So let's make this 5 meters. And then what I'm going to do is I'm going to try to make this exactly the same angle by duplicating this. And bring it closer. And then I'm going to shrink this down. Great. So if I've done this more or less correctly, okay, this theta should be the same. Okay, these are the same angle. Okay, but obviously I'm not looking as high anymore. Okay, when you walk 10 meters directly towards it and look up at the same angle, you see a window that is 6 meters below the top of the building. So what I can do, and I think maybe what's easier to do, is let's call this distance x and this distance x plus 6. It's not very pretty. Okay. And then what I can do is kind of like consider both of these triangles. By the way, these are similar triangles, right? Okay. So we could actually solve this probably using similarity, but we are in trig, so let's do this using trig. So the bigger triangle has these dimensions, 15, x plus 6, and theta, and the smaller one is theta, x, and 5. So what I can do is actually create a system of two equations to help me figure out x, because I don't have enough information. I have theta and x in both pictures, so I'm going to need two equations with the two unknowns. So I have tan theta is opposite over adjacent, and in this one I have tan theta is also opposite over adjacent, right? And tan theta is the same. So what I can do actually is I can say, hey, I have a system where tan theta is x over 5 in my first equation. In my second equation, tan theta is x plus 6 over 15. So what I can do is set 1 equal to 2 and substituting tan theta, x over 5 equals x plus 6 over 15. Then I can cross multiply. I get 15x is 5x plus 30. That means 10x is 30, and x equals 3. Okay, so I can go back up to here and say, well, I know that this is 3 and this is 9. Okay, but remember, this is asking me the angle of elevation. So now I can pick either of these two triangles. Maybe let's pick the smaller one because it's easy. So if this is 5 and this is 3 and this is theta, well, now I can solve for theta using my inverse tan button. Tan inverse 3 over 5, theta equals 30.96. So we can say the angle of elevation is 30.96 degrees. All right, 2 more examples. All right, standing on a street, you see a fire break out on the roof of a building at an angle of elevation of 75 degrees. Lower down, you see a person in the window at an angle of elevation of 65 degrees. The direct distance between you and the fire is 5 meters more than the direct distance between you and the person. How tall is the building? All right, so we've got a fire up here. Okay, this is you. Okay, when you look up to the top of the building, you have an angle of elevation of 75 degrees. Okay, and then when you look lower, you see a person there. This is not going to be to scale. And this angle of elevation is 65 degrees. So you see a person here. And it's asking you how tall the building is. We also know that if your distance between you and the person is x, the distance between you and the fire is x plus 5 because it's 5 meters more. So direct distance means directly from you to the thing, not the perpendicular distance or the horizontal distance. Okay, so what we're going to do is use 2 different triangles to figure out the height of the building. So let's denote this as h, okay? And then what we can do is we can do a similar thing to what we did last time, where we separate the 2 triangles out and we try to figure out what we know and what we need to know. So there's my smaller one. There's my bigger one. And I can actually notice that it has one thing in common. it has this base distance in common. Let's call it B. So I know that both triangles have distance B and B as their base. One hypotenuse is x, the other one is x plus 5, 65 degrees and 75 degrees. So we're in this situation again where we have two equations and two unknowns. So let's see what we can do here. I'm going to use the cosine ratio because I know I want to relate my adjacent side with my hypotenuse. So it's b over x. And here I have cos 75 degrees equals b over x plus 5. I have equation 1 and equation 2. And what I'm going to do actually is just rearrange these so that I have b isolated. So what I did was I cross-multiplied and I isolated for b. I'm going to do the same thing here. I get b equals x plus 5 cos 75. And the reason I'm doing that is so I can sub 1 into 2. Okay? So in my next line, I'm going to say x times cos 65 degrees equals x plus 5 cos 75 degrees. And then what I'm going to do is go into my calculator. I'm going to write down the 4 digits of cos 65. So I have 0.4226x, and then x plus 5, x plus 5 times 0.2588. Okay, I am going to distribute 0.2588x plus 1.2941. I'm going to bring the 0.2588 over. And I get 0.1668x equals 1.2941. So x is 7.7584. Now something tells me this is not what I've been asked to find. Is it? No, it's not. Because it's actually asking me for the height of the building. So what I want to keep in mind is that the thing I'm actually being asked to find is the height. Okay, so the next thing I need to do is go back to my picture, the bigger one, and I know that x is 7.7584 plus 5, which is 12. Actually, we can just leave it like that. That's fine. Okay. And then I know this is 75, and this is h. I actually don't need to solve for b itself. I don't need the base at all. But here I can say tan, no, not tan. We have opposite over hypotenuse. So it's going to be sine 75 degrees equals h over 12.7584. So h is 12.7584 times sine 75 degrees. And we actually get that h is 12.3237. So somewhere here I can say that the height of the building is 12.32 meters. Nice. Okay, we've got one more. A flagpole has 2 guy wires attached at the very top. Guy wires are supporting wires and they're very, very strong. The angle of elevation of one wire is 55 degrees and the angle of elevation of the other wire is 65 degrees. One wire is 5 meters longer than the other. How long is the flagpole? So here's my flagpole. I'm going to give it a height of h. It's perpendicular to the ground, and we have 2 wires. We have one with an angle of elevation of, let's do 65, and the other one, which has a smaller angle of elevation, this is 55. Now this is not a trick question where it says one wire is 5 meters longer. There's only one obvious choice for this, and it's the one with the lower angle of elevation. This one definitely requires more wire than the one that's obviously closer because it has a higher angle of elevation. So again, we're going to need two equations and two unknowns. So the first one is going to be sine 65 degrees equals opposite over hypotenuse, and that's this triangle here. The second one is sine 55 degrees is opposite over this hypotenuse. Okay, and again, what I'm going to do is I can think about this as cross multiplication. So h equals x times sine 65 degrees. Okay, that's equation 1. Equation 2 is h equals x plus 5 sine 55 degrees. Okay, and I'm going to solve this in a slightly different way. What I'm going to do is not use my calculator yet. I'm going to wait until the end. Okay, so this question is very similar to the one before it, but I'm not going to jump to my calculator just yet. What I'm going to do is use distribution on the right-hand side here to write this as x sine 55 degrees plus 5 sine 55 degrees. Okay, so it's like distribution like this. Okay, and now what I want to do is put the x's on one side. So I'm going to bring the term on the right-hand side involving x over to the left-hand side. 5 times sine 55 degrees. And then what I'm going to do is this fun thing where I factor out my x value. So I can see that I have x in both of these. So remember, factoring is like kind of like division, but it's also like the reverse of distribution. So if I take x out and I write this as sine 65 degrees minus sine 55 degrees, okay, it's like reverse distribution, right? Okay, so now what I'm going to do, I'm just going to rewrite this here. Actually, I'm just going to move this here. Okay, because remember, the name of the game here is isolating x. So the way I'm going to do that is I'm going to divide both sides by sine 65 minus sine 55 degrees. Now, if you're not comfortable with this, the reason I'm doing this is to cancel this out. Now, if you're not comfortable with this, you can go right to your calculator in a previous step and just write out all the decimals. Okay, but I like doing this because it keeps my answer nice and accurate right up until the final step, and I don't have to look at all the decimals. Okay, so I'm going to get 4.0958 divided by 0.0872. So x is 46.9702. So I have to remind myself what we called x. So x is the length of the guy wire, but it's actually asking me how tall the flagpole is. So what I need to do is go back to either one of these triangles. Let's go to this one. So I know that the guy wire on this side is 46.9702 meters long. Okay, so I'm going to call this h, and now I can say that sine 65 degrees equals h over 46.9702. H is 46.9702 times sine 65. And the very last calculation is 46.9702 42.5694. So we are going to say the flagpole is 42.57 meters high. Okay. So a bit more in depth, and you can see that most of these questions have actually two right triangles involved together, and sometimes that means you need to use a system of equations. Okay, hopefully this was helpful, and good luck with the homework, guys.